frequency to voltage converter. So this figure shows VFC 32 connected as a frequency to voltage converter. The capacity coupled input network C3 R6 R7 allows standard 5 volt logic level to the comparator input. The comparator triggers the one shot on the falling edge of the frequency input pulse. The threshold voltage of the comparator is approximately minus 0.7 volt. The frequency input waveform less than 5 volt logic level, the R6 bar R7 voltage divider can be adjusted to a lower voltage to assure that the comparator is triggered. Larger value of C2 reduces the ripple in the output voltage. Smaller value of C2 allows the output voltage to settle faster in response to change in the input frequency. Resistor R1 can be trimmed to achieve the desired output frequency at the full scale input frequency. For each negative spike of V01, the comparator triggers one-shot multivibrator which has threshold voltage of 7.5 volt and a charging current of 1 milliamps. The output multivibrator closes the switch, pulling 1 milliamps out of C2 assumes Fi to be input frequency. The pulse current is given by Fi into 1 milliamps into Th, and the continuous counterbalancing current is given by V0 by R, where V0 is equal to 10 power minus 3 into Th into R into F. So this is my output waveform of frequency to voltage converter. Negative spike at the V01, I am getting a output. In this video, we are going to see about voltage to frequency converter. The voltage to frequency converters produces an output signal whose frequency at any instant is function of external control input voltage. The output frequency Vfout is equal to kV into Vi, where kV is the voltage to frequency converter coefficient and Vi is my input voltage. Features of voltage to frequency converter: it operates up to 50 kHz, excellent linearity, voltage to frequency conversion or frequency to voltage conversions are possible, it is monotonic, and it is having voltage or current input. Application: it is used in integrating analog to digital converter, serial frequency output, isolated data transmission, FM analog modulation and demodulation, motor speed control and tachometer. Here I am using VFC 32. It is a voltage to frequency converter, provide an output frequency accurately proportional to its input voltage. The digital open collector frequency output is compatible with all common logic families. Its integrating input characteristics give the VFC 32 excellent noise immunity and low non-linearity full scale output frequency is determined by an external capacitor and a resistor, and it is scaled over a wide range. VFC 32 can also be configured as frequency to voltage converter. So this is a pin diagram of VFC 32. So second, third, 9th, 8th and 6th pin is no connection, and 13th pin is V output, 7th pin is F out, 5th pin is one shot capacitor, 11th pin is common, 10th pin is comparator input, and 1 and 2 is my inverting amplifier input and non-inverting amplifier input. So this is a block diagram of voltage to frequency converter. So here you have an integrator. So here my the signal input current is which is equal to V in by R1, and after integrating I will get a output called V in INT, and this is given to a negative input of a comparator. Principle of operation. The VFC32 operate on principle of charge balance. The signal input current is equal to V in by R1. This current is integrated by input op amp and C2 producing a downward ramping integrator output voltage. When the integrator output ramp to the threshold of the comparator, the one shot is triggered. The 1 milliamps reference current is switched to the integrator input during the one shot period, causing the integrator output ramp upward. So you can see here. So here my integrator output goes down. Whenever 1 milliamps one shot is triggered, it goes upward. After the one shot period, the integrator gains ramps downward. The oscillation process forces a long-term balance of charges between the input signal current and the reference current. So the equation for charge balance is I input is equal to IR average. V in by R1 is equal to F0 TOS 1 milliamps. So this is my output.